On the third formative assessment, our first problem was to solve a rational equation. We are asked to find all the real solutions to this equation, to justify each step, and then to identify any extraneous solutions and explain why they are extraneous. So let's get started. I've been given this rational equation. It is the difference between two rational expressions on the left, and that difference equals another rational expression here. So whenever we're adding or subtracting rational expressions, we need to find a common denominator. And also, in order to solve an equation that has rational expressions in it, we really need common denominators on both sides of the equation. So I want to think about all three of these denominators and try to figure out how to make a common denominator. And here's what I'm going to do. First, I'll just start by factoring the left-hand side of this function. And it factors pretty easily. It's just a quadratic with a couple of binomial factors. And that looks good because I see the x plus 4 and the x plus 3 on the other side of the function. So each of these rational expressions on the left-hand side, they're just missing one or the other factor that we have here on the right. So that makes it pretty easy to get a common denominator. Let me just justify this before I move on. I just factored the denominator. That's all I did. Now, I can take this first rational expression, and if I want to multiply the bottom by the missing factor, right, x plus 4, if I want to multiply that factor in here, then I also have to multiply the numerator by that same factor. There we go. I'm really just multiplying by 1, these two factors. Really, we could cancel them out if we were simplifying this, but I'm actually multiplying it out so that I have a common denominator. Over here, I have my original rational expression, the second rational expression on the left-hand side, and I'm just going to multiply the top and the bottom by x plus 3. X plus 3. And now I've got my common denominator on both of these rational expressions. And on the right-hand side just stays the same. X plus 4 times x plus 3. And what did I do? I found common denominator. So I can go ahead and carry out this multiplication now on the left-hand side. And I'm going to do that, and I'm going to actually subtract. So I'm going to just do all the arithmetic over here that I need to. X times x plus 4, that's the numerator of the first term, minus 2 times x plus 3, the numerator of the second rational expression. And this whole thing is divided by x plus 3 times x plus 4. There's my denominator. And that equals 2 divided by x plus 4 times x plus 3. My right-hand side just stays the same. So I will say that I simplified the left-hand side. I just abbreviate left-hand side like that. It's fine. So now comes a bit of trickery. I'm going to multiply both sides of this equation by the denominator. If I multiply the left-hand side by x plus 3 and x plus 4, then those factors on the top will cancel with the factors on the bottom, and I'll just be left with x times x plus 4 minus 2 times x plus 3. And on the right-hand side, if I multiply the right-hand side by x plus 4 and x plus 3, those factors will cancel, and I'll just be left with the 2. Now, there's a lot of sort of ways to describe what I just did, but really the justification for this step is the reason what I really just did by multiplying both sides of this equation by that denominator is I used the multiplicative property of equality. And I will just abbreviate it like that. And now I just have this pretty simple equation to solve. Let me multiply it out on the left-hand side. X squared plus 4x minus 2x minus 6. And that equals 2. Okay, that's using the distributive property. And then I can kind of clean up the left-hand side by combining like terms. X squared plus 2x minus 6, and that equals 2 still. So this is combine like terms. And it looks like we have a quadratic here, so we will have to solve that. And the first thing I want to do when I'm trying to solve a quadratic equation is I would like for one side of my equation to equal 0 so that I could hopefully factor and use the zero product property. If not, I can use the quadratic formula. But what I'm going to do is I'm going to subtract 2 from both sides so that I get a 0 on the right-hand side. And that's the subtractive property of equality. So this factors pretty nicely. X plus 4 times x minus 2 equals 0. Every time I factor, I just multiply it back out in my head. There's my x squared. I got a 4x and a negative 2x, and that leaves me with 2x when I combine those. And then 4 times negative 2 is negative 8. I just want to check and make sure I factored properly. Factor. And then according to the zero product property applied to this equation, x plus 4 equals 0, or x minus 2 equals 0. And that's from the zero product property. And so my final solution is x is equal to negative 4 from the first equation, or 2. And that comes from the properties of equality. Whenever you do something to both sides of an equation, like add 2 to both sides or subtract 4 from both sides, you're using the properties of equality. So there we go. Those are my values of x that I got. But remember what the instructions say. They say identify any extraneous solutions and explain why they are extraneous. Well, the thing that causes solutions to be extraneous is if you take them and plug them back into the original equation, and if they cause the original equation to be undefined, well, that just means that it's not really a solution, because it doesn't cause the equation to be true. It causes the equation to be undefined. And if you look at this line right here, right after I factored the denominator, you can see that if x is equal to negative 4 or if x is equal to negative 3, it causes one or more of these rational expressions to be undefined, which causes the entire equation to be undefined. Well, I got 2 solutions for x. So I'm going to just make a note down here in order to complete this problem that x equal to negative 4 is extraneous because it causes the original equation to be undefined. So really I just have one real solution, 2, and then I have this extraneous solution. And just a bit more information about this problem. When we go from this step to this step, what we're really doing is we're multiplying by the denominator, and then we're canceling out these terms. So we took a rational equation and we turned it into something that's not rational. And that's what caused, we threw away some information there, and that's why we were able to arrive at this solution. That's also why we need to go back and check for extraneous solutions.